Okay, I'm going to continue with the videos on word problems. This will be lesson 1.2, and these will be a couple of word problems dealing with a person's age. So let's look at the first problem. And again, what you want to do at the beginning is read the problem carefully. Make sure you understand what they're asking you for. And then think about what plan you're going to use. How are you going to set it up? Are you going to use an equation? In most cases you will. Okay. So the first one states Dave is 20 years older than Jim. In 5 years Dave will be twice as old as Jim. How old are Dave and Jim? So we're going to find the ages of the two persons. So that's pretty straightforward. So we set it up. We're going to use an equation. So obviously we're going to deal with variables, x, y. That's your choice. Doesn't matter what variable you pick. But here's the way I set it up. I said let x equal Jim's age. And then Dave is 20 years older than Jim. So Dave's age would be 20 more than x plus 20. Okay, or you could say let x represent Dave's age, then x minus 20 would be Jim's age. Okay, you get the same setup. Eventually your answers are going to be the same. Okay, but this is one way to set it up. And then we just use the information. States in 5 years. Okay, so in 5 years, that means we add 5 years to Dave's age and 5 years to Jim's age, and Dave will be twice as old as Jim. Okay, so the equation will look like this then. X plus 20 says in 5 years Dave will be twice as old as Jim. Okay, so this is Dave's current age, x plus 20. So I'm going to add 5 to this. Dave will be, so that means equals, will equal then twice, that means double. So that's 2 times whatever Jim's age is in 5 years. And if Jim is x years, so in 5 years he would be x plus 5. And that's the main thing about setting up a word problem, making sure the equation is set up correctly, and then from then it's just using basic algebra. And again, most of these word problems that I'm going to be looking at you require from just basic algebra up to say college algebra. And I've done a lot of videos on basic algebra, college algebra, so check those out either in this channel or go to the introductory channel video and click on my other channel, okay, Dr. T channel. So in this case, and I simply solve this equation. X and then 20 and 5 is 25. And then on the other side I multiply through distributive property. 2 times x will be 2x. 2 times 5 is 10. Okay, it's a linear equation, first degree equation, very basic. All we have to do is isolate the variable, so we want to get the x on the same side. So we got an x on the left side, a 2x on the right side. So let's get them all. Doesn't matter which side. I'm just going to say let's add a negative x to this side and a negative x to this side. So if I do, that'll give me 25. X and negative x will cancel, and then negative x and 2x will give me x. And then plus 10. Okay, so now I want to isolate the x. I want to get rid of this 10, so I said, well, let's add negative 10 to both sides. So if I add a negative 10 to the right side, the negative 10 and the 10 will cancel, go to 0. And if I add a negative 10 to the right side, I get x is equal to 15. Okay, So x is equal to 15. That's Jim's age. Okay. So Jim then is 15. And Dave is 20 years more than that. So 20 added to 15 will give me 35. So there you have it. Those are the two ages, Jim's age and Dave's age. And you can kind of check it out. You can see in 5 years, Jim will be 20. In 5 years, Dave will be 40. So 40 is twice 20. So again, when you work out these problems, you get an answer. Make sure your answer it makes sense. Check it out in the context of the problem. Just to make sure you're correct. Okay, so the answer is 15 and 35 in this one. Let's clear this. Go to the next one. Okay, we have Grandpa Joe has a daughter who has 3 children. The daughter is half the age of Joe, and grandchild number 1 is 1/5 the age of Joe. Grandchild number 2 is 1/10 the age of Joe, and grandchild number 3 is 1/16 the age of Joe. If the sum of the ages of the daughter and the 3 grandchildren is 69, how old is Grandpa Joe? So in this case then, we're dealing with age again. So obviously I need something to represent the age of the mother and of the 3 grandkids, and then based on what they tell me, if I add those up, that's supposed to give me 69. So that's pretty straightforward, I hope. So here's the way I set it up. We're looking for Grandpa Joe's age, so I'd let x equal to Grandpa Joe's age. The daughter is half his age, so that would be x over 2 would represent her age. The first grandkid is 1/5 the age of Grandpa, so that would be x over 5. The second grandchild is 1/10 the age of Grandpa, so that would be x over 10. And then the third one is 1/16 the age of Grandpa, so that would be x over 16. So based on what they tell me then, if I add the ages of the mom and the 3 grandkids, okay, so that would be x over 2 plus x over 5 plus x over 10 plus x over 16. According to what they tell me, this is supposed to equal to 69. Okay, and this again is a first degree equation. We don't have any x squared or x cubed, it's just plain old x. So it's just a matter of combining the expressions on the left side and solving for x. Now to make it easier, you might want to go ahead and multiply by the LCD, or lowest common denominator, to get rid of the fractions. Okay, so in this case, the 2, the 5, the 10, and the 16 will all go into 80. Just basic arithmetic there. Okay, so we can use 80, or we can use any number that's a multiple of 80, and it'll still work. But usually we want the smaller number to make it easier on the calculations. So I multiply both sides of the equation by 80. That's legal, okay, as long as you multiply both sides by the same value. And that's going to clear the fractions, because notice 80 times x over 2, the 2 goes into the 80 40 times, so the first term reduces to 40x. Multiply the next term by 80. 5 into 80 is 16. So that reduces to 16x. Okay, next term multiplied by 80. 10 goes into 88 times. So that reduces to 8x if I multiply by 80. And then multiply the next term, the x over 16 by 80. 16 to 80 is 5, so that then will reduce to 5x. No fractions now. And then on the right side, I'm multiplying by 80, so it's 80 times 69 is 55. 20. And then I combine this, 40 and 16 and 8, or 40x I should say, 16x plus 8x and 5x comes out to 69x, just combining terms. So I get 69x is equal, that should be equal here, to 55. 20. So now just a matter of solving for x. So I'll divide both sides by 69. So 69 divided by 69 cancels. So this will just give me x on this side. And then 55/20 divided by 69 is 80. Okay, so we're looking for Grandpa Joe's age. So he's 80 years old. Obviously, if you wanted the age of the mom and the grandkids, you could easily get it from the setup over here, right? The mom is half his age, so she would be 40. The first grandkid is 1/5 his age, so that would be 16. The next one is 1/10 the age, so 1/10 of 80 is 8. And then the next one is 1/16 the age of Grandpa, so 80 divided by 16 is 5. So you can easily find the ages of the other people involved, but here the main thing they wanted was the age of Grandpa. So he's 80 years old. Okay. So again, we'll continue in the next video with a few more problems, and they'll get a little bit more complicated as I go through there, require more concepts from algebra. And again, if you need more review on just basic algebra, solving equations and so forth, check out some of my other videos on this channel and then on my other channel, my Dr. T channel. And again, if you have any other suggestions, please post them. But for right now, unless I hear from you guys about other types of videos, I'll be looking at a variety of videos on word problems. So again, as always, please subscribe, and we'll see you in the next video.